This is yet another set of student data where I asked them to tell me what their gender was, what their height was, what their favourite colour was, which month of the year they were born in, how many siblings they've got, how important statistics is to their job, how important the statistics is to their degree, and how positive they feel about statistics. So in this case, I've got an awful lot of data. So I've now got 682 people in the list. So that's quite a lot. And what I'm going to do this time is I'm going to summarise height. So I'm going to look at the properties of height. Now, height is a scalar, it's a continuous variable. So what do I want to do? I want to summarise it. If I go to Analyse Descriptive Statistics and Explore, I can do a complete summary of height. So in this case, I'm going to do the statistics and the plots. Percentiles. So I can do my 5-figure summary, and I can switch on plots. Now it does stem and leaf, but I also want to do histograms. I'm not particularly keen on stem and leaf, but histogram I find easier to look at. Now you should always, when you're dealing with scalar data like this, measurement data, you should always plot a histogram so that you can check for normality. There are formal ways of testing for normality, which I mentioned there, so the normality plots, which I'm not going to do at this particular time. It is often good enough just to look at the histogram. If you've got a very small data set, your data is never going to appear normal just because you've got very little sample and it doesn't make the shape. But if you get a bell curve in your histogram, you can reliably believe that that data is normally distributed. The only thing you're going to raise a concern is if you end up with two peaks, or if you have a very long skewed tail. But for most biological data, it shouldn't be not normally distributed. The normal distribution is general in most biological cases. Right, so I press OK. So the key thing about this is you get a complete summary of your data. So you have the mean, you have its confidence intervals, you have its trimmed mean, the median, the variance, the standard deviation, the minimum, the maximum, the range, the interquartile range, the skewness, and the kurtosis, and also the standard error. I clicked on for percentiles, so here is the first quartile, the 25th percentile, here's the third quartile, which is the 75th percentile. The heights are roughly normally distributed, but here there's some clear things which suggest outliers. There's some odd values, particularly large and particularly small values, and you can see this when you get to the box plot, that all of these ones have been labelled as very unusual. So here, the blue bit is the interquartile range, the dark line is the median. This is the third quartile, the top of the box is the third quartile, the bottom of the box is the first quartile, and these whiskers represent 1.5 times the interquartile range. So this is telling you how much variability, and anything beyond those lines is something very unusual that you need to take a look at. Now, I summarised all of the heights. What happens if I want to ask a question about heights of men and women? So I go to Analyse, Descriptive Statistics, Explore, and now I put the gender in as a factor. So factors are anything that can divide your data into subgroups. So in this case, I'm going to do it by gender. Now if I press OK, instead of getting a table which summarises absolutely everyone, I get a table which summarises the female and the male. So now I've got a mean of 1.63 for women, and I've got a mean of 1.78 for men. So there's a difference. If I look at the confidence interval, it's 1.62 to 1.64, and this one's 1.76 to 1.80. This is telling you that men and women have different average heights. There's also prefer not to say as an extra gender. Prefer not to say, because that's a small number of people, this is much less reliable as an estimate. So here if I look at the quartiles, it's 1.58 to 1.68 for women, it's 1.70 to 1.82 for men, If I look at the histogram for women, it looks very normally distributed, but again there's some outliers. Particularly interesting is the one that's an outlier over 2.4 meters, and in men it's the same, apart from the histogram is shifted a little bit to the side, so it's got an average about 1.8, whereas the average here is about 1.6. And for prefer not to say, there's just such a small number that you don't get any kind of histogram. The stem and leaf plots you see similar to the histograms, and then you have the box plots. Now here you can see what happens to a box plot when you've got a small sample size. The interquartile range goes up massively. So in this case there's also a slight asymmetry in that the median is not in the middle of the box. For women it's in the middle of the box, for men it's not in the middle of the box. So there's a bit of a skew towards taller people rather than shorter. This is slightly unexpected, but perhaps because there's less men contributing. Here are the outliers and the suspicious values that you need to go back and have a look at. Dealing with outliers is complicated, and that's something for another video.